What I want to do now is show you how you can use completing the square along with substitution to evaluate an integral like this. Now, notice, keep in mind, recall that if we have this integral, x squared plus 1, like this, we know that that's arctangent. And of course, that's not what we have here. We don't have x squared plus 1. We have x squared plus 2x plus 5. So here's what we want to do. I want to see if I can turn this into something that maybe looks like this. So I'm going to factor out the 2 up top, and I just have the dx. And on the bottom, I have the x squared plus 2x, and then I have the plus 5. So I'll put the plus 5 on the outside. Now remember, completing the square, we're going to take half of this 2 and square it, and I'm going to add that, well, half the 2. Half the 2 is not 2. Half the 2 is 1. So I take half the 2, I square it, and I add that right here. Now, I can't just add something there. I need to subtract it off over here. So it keeps everything, balanced. Because really what I've done is I've just added a 0. A plus 1 here and a minus 1 here. So I had to counteract it. I just can't leave that 1 stand like that. Now, what this gives us is the following. Up top we have the dx, but on the bottom, notice I can rewrite this part here as x plus 1 squared. And then I've got the 4 here. Now this is looking a little more like this, but not entirely. We've got something squared, but not plus 1, plus 4. So let me just factor out that 4. Okay, so I'll factor out the 4, bring it out front, the 1/4. See, it's 1/4. And now I have dx over x plus 1 over 2 squared. Let me just write it that way. See? There was a 4 under here, and I just decided, okay, I'm just going to put it under this x plus 1 and square the whole thing. So right here, this part right here was x plus 1 squared over 4, but I wrote it this way, x plus 1 over 2 all squared. Now, what I can do now, and notice this is reduced to 1/2. So I've got this. I've got 1/2, and so let me just clean it up a little bit. Dx over x plus 1 over 2. Now, here's what I want to do. This isn't entirely like this. I don't have x squared. I have x plus 1 over 2 squared. So what I'll do is I'll just let u equal x plus 1 over 2. And then immediately I get du equals 1/2 dx. And notice that's exactly what I have here. I have 1/2 dx. So I can rewrite this now. My new integral, in place of 1/2 dx, I'll just put du. And then in place of x plus 1 over 2 squared, or x plus 1 over 2, I'll just put u. This is what I have now. So I can immediately notice that that is arctan. So here we have it. This is arctan u plus c. And then if we want, we can substitute that back in and have arctan x plus 1 over 2 plus c. And there we have it. So that's how you can turn something like this into something that's more familiar. In this case, arctan.